Have you ever wondered about what happened before the Big Bang? The key to finding out might actually lie in the depths of the black hole.
Imagine you're a star. Not that kind of star, but a sunlight star, except with a mass that's 20 times more than that of our sun. You look around and you think, these objects are only attracted to you because of your insanely attractive gravitational force. While Newtonian physics does look at gravity as only a force, now is a good time to look at this in terms of Einstein's gravity, a distortion of space-time. The massive star's matter bends the fabric of space-time itself, which is why objects which can otherwise travel in a straight line seem to follow a curved pathway. As an analogy, if the space-time fabric was like a net, you can see how massive objects in space can attract each other. However, the effect of gravity in an object can still be calculated using Newton's law, which depends on its mass and its distance from the star. Being much more massive than the Sun, this star will eventually end in a supernova explosion, after which the mass of the remaining matter is high enough to collapse back together in the fabric of spacetime. The remnants keep collapsing so much under gravity so that eventually all of the matter is concentrated into volume zero size. Welcome to the black hole. Hold on. If it's got a zero volume, does it even exist? How about its gravity? Remember, it's still got a mass equal to the remnants of the explosion. Simple math shows us that the effect of gravity, and therefore the curvature of spacetime, is infinite. So unlike a star of finite volume, the black hole curves space and time infinitely. Behold the singularity. Mind you, this isn't a location or an object of compressed mass. Rather, it's like the edge of spacetime itself, a bottomless pit if you will. In math, it's just an abstract point of an infinite quantity, but in a black hole, the singularity is why an object traveling in a straight line from A to B would have to travel an infinite curvature, taking an infinite amount of time. So if you watch a space cat go into a black hole, all you see is that it slows down as it gets closer and closer and completely stops at the event horizon, only to get redshifted before disappearing. That is, you'll never actually see it enter the black hole, much less cross it. But for the cat itself, it would be the complete opposite. Time outside the black hole would just run faster and faster, and more importantly, the cat would know that it really did go into the black hole. So in a sense, to us as distant observers, anything beyond the event horizon only exists in the future, an infinite time away, so we never actually see it. This diagram of the Big Bang explosion looks familiar now, doesn't it? Scientists think so too. So going back to the first question, scientists think that the Big Bang can be traced to something of the sort of a black hole, which means the entire universe as we know it could have emerged from a singularity far, far away in time. And no, physics is not magic, but it's similar, so go wild.